Hi, this is Dean from TRS Survival. Today we've got another Bushcraft or Bullshit video for you. This one is about creating a solar still out of everyday items to distill salt water into drinkable water. The biggest concern that I had after seeing this was finding the right combination of container sizes. We've got a standard soda can here. We've got a standard, canned food can. We've got something that's a little more unique, a little juice can. These aren't that common, but they are around. Maybe you could make something out of the environment. You could probably, if you had aluminum foil, you could probably make your own little container. But just right off the bat with this hack, the problem that I see is, yes, it might work in theory, but you've got to have the right combination of container sizes in order to make this work. So we'll start with this one. It's the thickest bottle. It has the largest diameter, so it would be ideal to use. But my concern is that it's going to split when we start trying to roll it up onto itself. But we'll give it a try and see. All right, so we've cut the bottom off. Now we'll try rolling this up. So this is working a little better than I expected, which is good. It is very irregular, but there is a cavity here, and there's only a couple of spots where the inside of the bottle is touching the wall where some condensation could be lost. I would say at most the volume it could hold would be, an ounce, maybe an ounce and a half. But if this works quickly on a sunny day, you might be able to actually get a reasonable amount of drinking water. And this is actually going to fit over a number of these containers. Maybe use this can, and we should be able to pinch it, bend it back and forth, and break it. So this would be another technique. A decent volume of water would fit in there. And this is a much easier fit with less risk of losing it once you have to pull it out. Should pull out much easier because the walls are thin and it bends. So we'll go ahead and fill this up with some salt first, and then some water. I would say the setup is minimal. It took me a couple minutes at most to get this done. And if I had a lot of bottles, I could probably set up 10 of these and then maybe get 10 ounces of water in a couple hours. So we'll let this set. We're going to set this aside in the sun, and we'll just check on it periodically and see what we get. So we let this experiment run for a couple of days. We were a little disappointed that we didn't get good results in a few hours. You'll see on the time-lapse video that there's a lot of condensation that builds up, but it hadn't yet started condensing and running down. That didn't happen until about 1 day went by, and I have some theories on why that happened. And I'll go ahead and pull this can out, and you can see the salt in there. All the salt is still in the can, and the water evaporated up and went down. It took about 3 days to fill up this reservoir with what would have been distilled water. You'll see that we did wrap a towel around the base. After, I think, a day, I started getting concerned about whether or not some of the water vapor was escaping, because this isn't completely flat on the bottom. And I was worried that because it was sitting and there was some airspace, that a lot of our water vapor was just leaving to the atmosphere. So I wanted to plug it up a little bit. So that's something that you could do in the field, or build some dirt up around the base to keep that water vapor that you've produced inside this container. So why did it take so long? It wasn't cool enough outside to actually condense the water. So when water evaporates and turns into water vapor, it's inside of the air, and it needs to have a reason to condense. So hot air can hold a lot of water vapor. Cold air doesn't hold a lot of water vapor. My theory is that the bottle wasn't cool enough for that water to condense really. It did very slowly, not really a drinkable amount. So I think at nighttime, when the temperatures went down, that's when we got a lot of condensation, and then the water droplets running down into the bottle. So it took almost that heating and cooling cycle to really produce results. So first off, I would say that this trick works technically, but not in what I would consider to be an emergency survival scenario. The volume of water that you get and the amount of time that it takes to produce it isn't something that you could rely on in the short term. If you say you had a lot of water and you had a lot of bottles, to set a bunch of these up and you are planning for the long term, hey, I'm gonna run out of water in the next couple of days, then this might be a way for you to produce some drinkable water. But if it was, hey, I need some water to drink or I'm gonna die in a day or two, I really think this is not gonna work for you. Maybe if it's your last resort, try it, because it technically does work, but we'll go ahead and pour this water out into here and just see how much water is in there. And I think you'll probably see why this isn't something that you could rely on as far as your sole source of water in a survival situation. So hopefully we won't lose any of the water as we flip it. I didn't get any drips on the asphalt here, and I got most of that water out, and I'm looking at less than 1/4 of a cup. I'm not exactly sure what that is in ounces. I think it might be like 1 ounce or something like that, maybe 3/4 of an ounce. So it is water. It did prove the concept, but whether or not it's something you could rely on to save your life, I'm pretty skeptical. One point that I would make is that if I was gonna set these up, I would set it up while the sun's still out in the afternoon. As far as like the best time to do this would be while it's still hot enough to create a bunch of water vapor, but it's gonna get cool very soon. As soon as the sun goes down, the bottle gets cool, suddenly you get that condensation and you get some water. So there might be other ways to do this, bigger bottles, different setups, but I feel like we gave this one a pretty good effort, and it kind of disappointed a little bit. So this is kind of a bullshit survival tip. It technically did work, but kind of bullshit. So hope you enjoyed, and if you want to see us test some more survival tricks, let us know in the comments below. If you have some ideas for us, we'd be happy to check them out and maybe do one in a future video. Thanks for watching.